Okay, good day, guys. Now this is Mr. Stole. Okay, so we are doing functions one. Okay, for grade 12. So we're going to cover today the definition of a function. So you have an understanding of what a function is. The domain, what is a domain, x of symmetry, asymptote, turning point, and also how to sketch the graph. Okay. Then lastly, we'll look into linear functions. Okay. So just some terms that you need to remember. When we're talking of a function is the relationship between your x and y values, okay, where for every x value, okay, for every input of x value, okay, you have a corresponding one y value, okay. So in the domain is set of x values. So whenever we're talking of a domain, you must always think of what is it, x values, okay. Then range, we are actually specifically talking of y values, okay. Then the x of symmetry is an imaginary line that divides a graph into two mirror images of each other. So that line that divide, I'll show you just now, okay. But that's what you need to understand when talking of axis of symmetry. Now, another thing that you need to understand is a maximum point. When talking of a maximum point, here we are referring the highest possible y value, okay, of a function, okay. So maximum, minimum, we're actually looking at the y values, okay. So y values, maximum is the highest, minimum is the lowest y value, where your graph tends. So it's actually the turning point. It's actually the turning point of your graph. So your turning point is actually either your maximum or a minimum, okay. Then an asymptote, and this line called an asymptote is an imaginary line, okay, that a graph, it just approaches it, but it never touches. So it never touches the asymptote, and that's what you need to remember then, okay. So let's see let's get to see here what's actually happening on paper here. Okay, so let's see what we have here. So we are looking at input values. Input values are your x values, okay, and that describes your domain, okay. That's what you must remember always. Then we have an expression that we're going to put here, and the output value is what we get, okay. What we get once we put in input value of what we substitute the x value with whatever we gave here into the equation, what is the output here? So the output is actually the range, okay? So let's talk of maybe numbers from, let's say, negative 2. So let's say negative 2, okay? And also 2, 0, negative 1, and 1, okay. And see, this is our domain, okay, is our domain there. So it's our domain in this case here is negative, from negative 2, okay, less than your x, less than what is it, less than 0, okay. That's what we have there. That's our domain there. That's how we write the domain. Now let's have an equation here, an equation. So when you're saying one-to-one function, remember here, one-to-one function, it means that it's a linear function. It's a linear function. Example here, a linear function. So in this case here, for every input of x, we get a corresponding one value of what called of y. So for example here, we input single value, we get a single value. So for example here, we have got maybe, let's say 3x plus 1, okay? 3x plus 1, that's our expression there. What we're going to do now is called mapping. So let's put negative 2 there. When you say, when x equals negative 2, what do we get here? We say, all right, 3, okay, negative 2 plus 1. What do we get? We get negative 5. So that's our output here. So we have negative 5. So if x is equal to negative 2 into our equation, we substitute that and see that what is it? It's negative 5. Then if we put 2 there, if 2 is positive there, let's see there. If 2 is positive, what do we get? We get a 7. So let's put here and let's get what? A 7 there, okay? Now, what about if x is equal to 0? What we have here is that 3 times 0 is 0. Then it will give us what? It will give us what called 1. Then negative 1, if 3 is equal to x equals negative 1, let's put negative 1 here. Okay. Let's put -1 here and see what we have there. It's going to be what? It's going to be -2. So we get -2 here. Then if we put, if x goes negative, it goes to 1, 3 times 1 is 3 plus 1 is 4. So what do we get there? We get a 4. So that's what we call one-to-one functions. Okay. Now, when we talk of many-to-one function, so this is sort of like f of x is equal to 3x plus 1. Okay. Then sometimes the question say find f of -2. That's where you need to substitute like what we did here. You just need to put where x is, you put to -2 plus 1 and you get your -5. That's what you're supposed to do here. Okay. Now, so many-to-one function. Now what you're going to have now, you put two values, okay, and you get the same value. Okay, now let's see what we're talking about here. Let's start again with the same domain. So our range here, our range is from what? So let's bring it back here. Our range is from -5, that's the smallest one, less than f of x, less than, what is it? The highest one is 7. So for this domain, actually the outcome there, or output there, the range there is from -5 to 7. Okay. Now let's have many-to-one here. So let's have 3x squared plus 1. Okay, let's have 3x squared plus 1. Now let's start again here. Let's put -2. Let's put it 2, let's put 0, -1, and 1, okay, and see what we get there. So let's put -2 into the equation. We're going to say, all right, -2, okay, we square that, okay, we square that plus 1. What do we get? We get 13. Okay, let's put 2 here and see what is the difference there. +2. We see what we get. We still get 13. So now we're inputting 2 values and we get a corresponding 1 value. Now, when you put 0 there, it's going to give us what? 3 times 0 squared is going to give us 1. It's give us the same answer there. Then what if we put what you call -1 here? -1. Let's put -1. What do we get? We get a 4. Okay. Okay. Then if we put 1 again, we still get the same answer there. So that's what we get. We still get a 4. So we put 2 values here, but it's just giving us 1 corresponding value. And the range now becomes what you call from 4 1 less than f of x, okay, less than, what is it? 13. That's what it means there. Okay. So that's what you need to understand there. That's what we call one-to-one function, many-to-one function. Okay. So this actually is a quadratic for quadratic function. Okay. Quadratic function. Okay. We're going to talk about it, but now let's see what is it function that we just talk about now. A function, we said it can be a linear, where this one is called a linear function, or it can be a quadratic, isn't it? But the main concept here that you need to understand here, what you need to understand here is that for every input of x here, for every input of x, we get a corresponding one y value. That's what we want. Then if it comes to this, okay, for every input of x, we get one corresponding value of y. Okay, but in this case here, if we put -2, okay, -2 and 2, we get the same value, which is 13. So in this case, it's a function because you have one output. So it becomes, now let's see here, let me show you something here. When we find something like this, okay, in this case here, this one is not a function. This one is a function. This one is not a function. Why not a function? Because you might get a question also like this to say, why is this a function? Okay, and sometimes what should you do to make it a function? But that one we'll do it later. But now the thing is, the only reason here is that The reason why it's not a function, because for every input of x value, there are two output y values. That's what you just need to remember there. There are two output y values, and we don't want that, because for every input of x, like this case here, let's put here x here. So it means that we have got this value of y, and it also also have the same value down there. So it means that now we are having two values, and this one becomes what called something else, which is not what called a function. So this one is a function because for every input of x, we get a corresponding one y value. Okay. So let's see what's happening next here. Okay. So here let's talk of let's talk about linear functions. So linear functions, this is what we have here, and linear function, another equation for linear functions, y is equals to mx plus c. Y is equals to mx plus c, where your m, so let's see here, y is equal to mx plus c. Your m is your gradient. Okay, when we talk of gradient, we're talking of steepness. Okay, then your C there is your y-intercept. When you are talking of y-intercept, you're talking of where your graph cuts y-axis. Y-axis, this line here. So where your graph cuts the y-axis is what we call the y-intercept. Okay, so what you need to remember here is just how to find the gradient and how to find the C. That's it, to what you call when you're dealing with the linear functions. So linear functions here, general equation, y is equals to mx plus c, and in general here, when you're saying this one is equals to y is equals to x, because it's touching on the it's touching on the center there. But now your y now, what does your y do now? Your y moves, it's called a vertical shift. It causes a vertical shift in your graph. So for example, if I say, all right, y equal to x plus 3, y is equals to x plus 3. Now it means that I need to move my original graph here, y is equals to x, 3 units up. So it will have to touch at what we call at 3 now. It's no longer at 0. So what you'll do, it will be like this. So this is 3, let's write 3 there. This is y equal to x plus 3. That's what we have there. Okay, so that's what you need to remember there only. Now, you know that x, my c is a vertical shift. The other thing again, gradient is we are talking of steepness here. So if in this case, let's say we have this one, you can see this line that I'm drawing now, it's more steeper than the original here. So this can be y is equals to maybe 5x. Now the gradient is no longer 1, it's 5x. That's why your line is more steeper than that, than the previous. So you don't need to worry much about sketching this, unless if you are comparing the two, unless if you are you're asked to sketch on the same graph. That's where you need to make sure that when it's having a bigger number here, okay, it needs to be steeper than the one with the lower value here, lower gradient, okay, because gradient determines the steepness, okay. Now, so let's see how to determine the equation. Determining equation. Okay, so here what we have is that we have a line here, okay, so don't forget to put your x and y and your center there. So we have a line here, what we have here, the straight line, okay, and you ask to determine the equation of this line, okay, this line here, AB, okay, and you know, first of all, that you need to do, you need to find the gradient first. Find the gradient, find m. So how do you get m? M is equal to change in y over change in x. And your change in y, you're going to say, change in y, you're going to say y2 minus y1 over x2 minus x1. Now, you need to be consistent here, because when you choose this one, these coordinates here, to subtract these coordinates, you must be consistent, because if you say, let's say you say 7 minus 3 minus 3, then after that you say minus 5 minus 1. you get something else. Okay, so you must always be consistent. When you start with these numbers, you must finish with on both. And if you start to say maybe -3 minus 7, you must start again here, -5 minus 1. Okay, so always be consistent with that. Now, m in this case is going to be what? Is going to be equal to, so y2, we say it's going to be 7, change in y, minus 3, okay, over what do we have here? 1 minus 5, okay? Then you want to see what you get there. Okay, so we say 7 minus 3, okay, then 1 minus 5. What do we get? We get 5 over 3. That's what we get is our gradient. Okay, our gradient is 5 over 3. Now, what do you need to do now? Second thing now is that you need to substitute, sorry. You need to find now, substitute into the general equation here. So general equation is y equal to y minus y1 is equals to m x minus x1. Okay, so use one of the coordinates. Use one of the coordinates. So you must use one of the coordinates. In this case, let's say you can use a. Okay, so in this case, let's use a. A is -5 and -3. Okay, now what do we do now? We're going to say y minus, what is y1 is -3 minus -3, okay, is equal to, what is m is 5 over 3, okay, in bracket x minus, what is x1? X1 is your -5, okay. Now, what do we get there? Y is equal to 5 over 3x. Now, 5 over 3x times, because this one is going to give you plus, okay? It's going to be saying, we're going to say, all right, this is the answer, okay, times 5. What do we get? 25 over 3. So we're going to say plus 25 over 3. But now again here, negative times negative is going to give us positive. So 3 is going to cross the equal sign. It's going to become negative there, okay? Because here, if you get a positive here, then you're going to say minus that one, minus 3. What do we get there? We get 16 over 3. So our answer there becomes 5 over 3x plus 16 over 3. Now, what do you need to do to remove what you call, to remove the fraction there, the 3? You multiply throughout by 3. So you get 3y is equal to 15, 15 what? 15x, okay? 15, oh, no, not 15x, sorry. Because this one is going to cancel, this one is going to cancel. So it's going to be equal to 5x plus 16, okay? That's our answer there. That's the equation of what called of the line, okay? But again, this is another method, okay? The other one you can use, okay? You can first find the gradient, yes. After finding the gradient, you have your gradient here, m is equals to 5 over 3, okay? Now what you need to do is to substitute one of the coordinates, okay, coordinates and the gradient into general equation to find what? To find C. So you have to find C. That's the problem. That's the second part there. And you know that the general equation here is y is equals to mx plus c. Okay. Now we choose equation. What call? Let's use the same coordinates here. We said a is -5, -3. So let's just see what we can do here. We're going to say y is -3 is equals to, what is m? 5 over 3. What is x? X is -5. What is c? Plus c, like that. Okay, then we take that one, that side is going to be, c is going to be, what is it? 25 here, negative 25 over 3. If you move that side, it's going to be positive 25, going to be 25 over 3 minus 3, okay? Then we get 16 over 3, okay? 16 over 3, that's what we get there. Now, when you do that now, you just substitute now in the equation to say the general equation now is going to be equals to m, you have it, 5 over 3, x plus 16 over 3 as well. Then you multiply by 3, multiply by 3, multiply by 3. Then you get 3y is equal to 5x plus 15, like that. That's how you can find it. Okay. So that's another formula that you can use to find what you call the equation of a line. So understand something here. When they give you gradient, let's say they say, all right, determine equation of a line, equation of a line, okay, with the gradient, with m equals to maybe -4, and passes through the coordinates, the point maybe, let's say it's it's maybe 5 and 7, okay. Now you don't need to worry now, you just need to come again with with the equation y1 is equals to mx minus x1, okay. Then these y1 and x1, these are your coordinates, okay. So you just have to say y minus 7 is equals to -4x minus 5, okay. Now what do you do now? Y is equals to -4x, okay. Minus gonna give you plus 20, okay. Plus 7, because here 7 you have to move that side. Then what we get there is y is gonna be -4x plus 27. That's how you can find it. Okay, so that's how you get the equation of equation of a line. Okay. Okay. Now let's see what you need to do. Now let's talk of sketching. Sketching a graph. So now when you are sketching a graph, what's very important here is the intercepts. Okay. So what's important there is intercepts, okay? So the intercepts, number one that you need to understand is what you call indicate intercepts. Okay, x in other words, x and y intercepts. Okay, so when you're saying x and y, where it cuts the y, where it cuts the x, that's it. That's what we want to know. We don't want to find any values between them. Okay, so you draw a graph. When you're sketching a graph, make sure that you indicate that's the x, y, because the Cartesian plane is must be very clean and must be very clear that it's a Cartesian plane. Now here is an x. Okay, we have an origin, we have a y there. Now you know that. All right, now let's begin now. So let's say they say sketch of what you call a graph of an equation. Let's say an equation is maybe, let's say it's y equal to maybe 4x plus 9, okay? Now, when they say 4x plus 9, now what do you need to do? When you want to find the x-intercept is only touches the x-intercept when y equal to 0. So you substitute y equal to 0 there. It's going to be 0 equal to 4x plus 9. Then 4x is equals to -9. Okay. Then x is going to give you what? X is going to give you, what is it? -9 over 4. So that's what we have here. Then when you have -9 over 4, this means that your coordinate in this case will be -9 over 4, 0. Okay, that's the first coordinate. Okay, that's on the first axis. Then the other one now is that your y-intercept. Okay, now your y-intercept is when x is equal to 0. But now you need to think something here. We said y-intercept is actually where what you call the value here, the value that you have here. Okay, the value that we have here. Okay. But now the tricky part is you just need to work it out, because sometimes you are having maybe it's 3y here. Okay, then you need to make sure that you work it out in this way. Otherwise, you just say, all right, I know that the 9 there is going to be my c, that's my y value. Yes, it's correct only if the coefficient of y is correct. Okay, so in this case here, we're going to say, all right, when x is equal to 0, y is equal to what you call? Y is equals to 4, 0, okay, plus 9, y is equals to 9. Okay, So in this case here, the coordinate is going to be equal to 0, 9. Okay, that's the coordinate there. So these are the two coordinates that you need to indicate only. So we're going to check here on our graph to say, all right, where should be 9? We say 9 here. Let's say 9 is here. Don't worry about writing 1, 2, 3, 4. No, we don't need that. It's a sketch. Nothing is done to scale here. Now, you have got negative 9 over 4. Negative 9 over 4 is more like 2 comma something, okay? 2 comma something, maybe it's somewhere here, okay? Negative 2 comma something is negative 9, negative 9 over 4, negative 9 over 4, okay? That's what you need to do. Then what do you need to do now after that? You need to connect your two lines here, connect here, your two coordinates here. Then after that, you label y is equals to 4x plus 9. That's it. Then you are done. That's how you're supposed to sketch. You sketch, when you're sketching a graph, you need to label it. You need to label your graph first. You need also to show that the x-axis, the origin and the y-axis, it must be very clear, okay? Then you need only to put the intercepts. That's what you need to worry about. So just to try to find out what is my value of what, why it is my value of y here and everything. All right, what I wanted to explain here, for those who didn't understand here, what I mean by saying, don't just pick up 9 there to say, this is my C. So for example, if the graph, if the equation is like this, 3y is equals to maybe 4x plus 9, okay? So when x is equal to 0, 3y is going to be equals to 4, 0 plus 9, which is 3y is going to be equals to 9. Then in this case now, you are supposed to divide by 3, both sides by 3, then y becomes 3. So that's what you need to think of there. So don't just rush into say, we know, yes, that the y, the x, they see there is actually for what call it's actually the y value there, but don't use that mostly because it's going to mislead you if in the case of this situation, okay? So always try to work out your things. Try to work out your things. Substitute for 0. Substitute for what is it? For 0 in this case as well in terms of y. Then you can find your values. So that's all for sketching. Okay. That's all for what is it for linear functions. That's what you need to remember only for linear functions. Okay. So this is the end, guys. This is the end, guys. Thank you so much. Okay. Don't forget to subscribe and also to follow us on Facebook, Instagram, and Twitter. Until next time, guys. Thank you so much. Cheers.